Hi, I'm Kerry and I'm an engineer. This National STEM Club session is focused on engineering and how materials and the structures within them make a difference to what a material can be used for. Engineers who design and create solutions for human problems have to think very carefully about what they use to make things. For example, you wouldn't make a mobile phone out of glass, imagine dropping it, and you wouldn't want a mattress made out of metal. In this National STEM Club session, we're going to do an experiment to see how different materials with different structures act when we push them to their limits. And the material we are going to push to its limit is chocolate. Yep, chocolate. We're going to see how different chocolate bars react when we hang weights from them. How much weight can a chocolate bar take before it snaps? And the extra good thing about this experiment, you get to eat the broken chocolate bars after. You are going to need to set up a rig, we'll get to that a bit later, but you'll also need to have things you can use as weights, a carrier or a way to hang the weights on the chocolate bar, and of course some chocolate bars. I've used 3 different types of chocolate bar. They're all roughly the same length and are all similar in shape, but they have slightly different middles. One has a honeycomb centre, another one is just chocolate but has air bubbles, and the last one has wafers in the middle. It's the middles that we are testing, the structures in the middle of the chocolate bars and how they respond to the test. I've made my own weights using airtight pots and water, though you could also use rice. By placing the pot and the lid on a kitchen scale and pouring in water, I've made a set of different size weights. The heaviest was about 1 kilogram, so 1,000 grams, and the lightest about 100 grams. If you don't have reusable pots, you can use other household items such as packaged foods or bathroom products. You just need to know how much each one weighs. Or if you don't have kitchen scales, just put the items in a set order, put in the heaviest ones first. Then when you add each weight during the experiment, you just need to make sure you add them in exactly the same order each time. To set up the experiment or the rig, you need it to do 2 main things. First, you need to be able to make a gap at the top for the chocolate bar to bridge. The gap needs to stay the same for every chocolate bar that you test. The gap I used was about 8 or 9 centimetres wide. The second thing the rig needs to do is leave room for the bag or whatever your method of hanging the weights without the weight touching the bottom or touching the sides. You need to make sure all the weight is hanging from the chocolate bar and not touching anything else. Other things that could work for the rig are 2 high back chairs placed back to back. Just make sure they have something on the seats to stop them falling over. Ultimately, what you need are 2 raised surfaces at the same height with a gap between them to put the chocolate bar, and it needs to be high enough so the weights don't touch the floor. As with any experiment, we have to make sure we've covered health and safety issues. You need to try to keep the top of the rig below head height. This stops anything from falling on your head. And protect what's at the bottom of the rig. There could be heavy weights dropping and you don't want to break anything or make a dent. Don't use anything for weights that might break or spill, and mind your toes and fingers. The key is to take it all very slowly, especially when adding the weights. Take a pause between each weight so it can settle in and you can make sure the chocolate bar hasn't broken. And make sure you keep the wrappers on the chocolate bars to test them. If we want our test to be about the materials and the structures of the chocolate bars alone, then we need to keep everything the same except the chocolate. By keeping everything else the same, we create a fair test, and a fair test means our results can be trusted. For this experiment, we need to ensure the following. We need to keep the space at the top of the rig the same for every chocolate bar we test. We need to try and get the chocolate bars that are around the same size and shape. Make sure the chocolates have been kept in the same place before you start the experiment and try to keep them at room temperature. When it comes to adding the weights, you need to do it in the same way. So if you hang them in a bag, you need to use that bag for each test. And if you're using random things from around the house as weights, make sure you add them in the same order. To begin, I'm going to hang the empty bag over the chocolate bar and then put the chocolate bar across the gap at the top. Taking the first weight, usually the heaviest one, I'm going to place it carefully in the bag. Try not to drop it, but place it carefully and then release the bag carefully. If you need to hold the chocolate bar at the same time, that's fine. For the first one, it usually helps and stops the chocolate bar from falling off. You're then going to keep adding weights until the chocolate bar snaps. Once it's snapped, you need to write down how much weight you added before it snapped. You probably want somewhere between 2 and 3 kilograms of weight for these chocolate bars. Others may need more or less. If you want to do the experiment before we talk about the results, press pause now. Hopefully what happened in your test is the same as what happened in mine. The chocolate bar with the wafers took more weight than the others. But can we explain why? It's all to do with the structure inside the chocolate bar and the fact that we're applying a force to it. The weight we are adding is pulling the material in the middle of the bar down. It's trying to bend the chocolate bar. And at some point, the force pulling down is greater than the strength of the material, so it breaks. Imagine if you and a friend were holding hands and someone tried to run between you. If they are stronger than your grip, the person can get through. Now imagine you have 3 hands on each side and your friend has 3 hands on each side and you're holding 3 sets of hands together. That would be much harder for someone to break through. That's a bit like what's happening in the chocolate bar with the wafers. The layers are bonded together and all the materials have a better grip on each other, which makes them stronger and therefore harder to break. If you enjoyed doing this experiment, there are lots of different tweaks that you can make to it. Depending on the weights you have, you can try to find the specific point at which the chocolate bar snaps. You can do this by adding smaller weights the closer you get to the breaking point. If we look at the diagram, we know a breaking point is after we've added the 4th big weight. So with the next chocolate bar, if we add the first 3 big weights in the same order, but then use smaller weights from there, we can work out a more precise breaking point. Or you can test more than one of the same bar and work out the average breaking point. This helps to make it more specific and more trustworthy. For example, 10 people telling you a book is good is better than 1 person telling you a book is good. Or you could try changing the structures in the chocolate. And a good way to do this is by making it colder or warmer. See what happens to the same type of chocolate bar if it's been sitting in the sun for 5 minutes or in the fridge for 30. There are lots of things that you could change to redo the test. If you go back to what's listed on the Fair Test section, these are all things that you can change and redo the experiment. The key, however, is that you only change one thing at a time. So good luck. I hope you had fun. Thank you and well done.